There we go. Okay. Okay. We'll be posting the replay to the CA security community later today, as well as the slides that Steve is about to present. And I will send a follow-up email to everyone who attended today's webcast with links to both of those pieces of content. And if you have any questions, you can ask those in the chat window or the Q&A panel, or you can hold your questions until the end of this presentation, and we will open the line so that you can ask questions over the phone as well. So thank you, Steve, and thank you, Terrence, for joining us today. We're excited to learn more about this.
Well, thank you very much, Kristen, and hi, everyone. This is Steve McCullough, and thank you for joining this fourth installment of our Summer Lunch and Learn series around CA Privileged Access Manager. I hope you are finding these sessions valuable. And as Kristen mentioned, I'll be walking you through a presentation, short presentation, introduce the topic, summarize where we've come from so far in this series, and then pass it over to Terrence Hooker, who will be doing a live demonstration for you. So the Summer Lunch and Learn series, this is the fourth installment. In previous sessions, we've talked about the need for privileged access management to defend yourself against the kill chain, and stressed other features of our solution, including the simplicity and some of the additional features that go beyond just our credential vault. Today's topic will be doing somewhat of a deep dive into how a CA Privileged Access Manager can help you address the vulnerabilities and risks associated with using privileged accounts inside your applications. Privileged access and privileged accounts is a very important problem for you to solve with regard to a breach defense. Some of the use cases that you've seen here and we've talked about in prior calls all involve the use or abuse of privileged accounts, privileged access. The motive for the attackers does vary. Sometimes they're looking for PII that they can sell. Sometimes it's outright credit card information, so financial gain. Sometimes it's intellectual property. Sometimes it's purely malicious. So the attackers' motives may vary, but the techniques they use are all very similar. And the use and abuse of privileged accounts was a key success factor in the breaches that you're seeing on this screen. In fact, all the breaches that you've heard about over the last few years did involve the use or abuse of high privileged accounts that allowed attackers to gain control by bypassing controls that regular users would be subject to. So privileged access as a countermeasure has become a very important defense. And what are these privileged accounts? Why do you even need them? What are they used for? So as you can see, that the legitimate use of these privileged accounts is that they're used by sysadmins, network admins, and other administrators. Everything that you use in your environment has the concept of a privileged feature, a privileged function that's hidden away from regular users and is entrusted to administrators for the legitimate purpose of keeping systems up, running, optimized, patched, and so on. The privileged accounts that they use have this high level of privilege so that they can bypass the restrictions that regular users are subject to so that they can configure these systems. And that's a very important job. That's what you pay the administrators to do. But with that privilege comes the potential for abuse. So the insider threat would be that these administrators who are performing their legitimate functions may also be using that privilege that they enjoy to do things that you wish they wouldn't do. Edward Snowden is the poster child of the insider threat. Who did things, certainly, whatever you think about him, he was not doing what his people who hired him thought he was going to be doing. And for our purposes today, we're also going to be looking at how applications make use of privileged credentials. Many apps have hard-coded credentials in them, and they do something that's very important because they're started by one user ID, but they need credentials of a different user ID in order to complete. That might be like an Oracle account, an application account, and so on. And so there's risk associated there as well that we're talking about. As you open your enterprise up to partners, remote employees, cloud-based applications like Office 365, Amazon AWS, other public cloud infrastructures, the problem of privileged access has kind of a multiplying effect. Privileged accounts are everywhere, ubiquitous problem, As you open up the enterprise to take advantage of these, you're going to find that those accounts can be exploited by a hacker. Sometimes a hacker might even use a programmatic way of breaching those accounts that results in malware in your enterprise. So privileged accounts are ubiquitous. It's a difficult problem to solve because you still want these administrators to be able to do their jobs, but you want to control unauthorized use of those privileged accounts, entrust it to the real valuable people, keep the bad guys out, and do that in such a way that everybody can still do their job. So the business goals of privileged access management are regulatory compliance achievements. So you may have an audit finding that requires you to demonstrate better controls around privileged accounts. I think most of us in the security field recognize that you can be compliant and still have residual risk. That risk would involve being vulnerable to targeted attacks by outsiders. So one of the goals of privileged access management is not just to get the compliance checkbox, but also to give yourself a better chance of defending against these attackers who are targeting your enterprise. Also mitigating insider threats. That has to do with just making sure that people who need the access are doing exactly what they need to do, but they're not doing things that unauthorized actions that could be outside what you would consider their legitimate job functions. Addressing the entire enterprise, so not just the few systems that you may have as your on-prem, or maybe that's a large footprint, but also consider your cloud-based apps, your infrastructure as a service, the remote access that you're granting, the entire hybrid enterprise. And being able to implement these controls while still allowing people to do their job. This enhancing the operational efficiency goes toward, hey, your administrators, you're doing something important here. I want to implement privileged access controls, but I don't want to make it so hard that you can't do your job. So that has to be something that you keep in focus. The countermeasures that we provide against privileged access management include the enforcement of strong authentication, either something that CA provides or something that you have from another vendor would be supported. The credential vault that we've talked about before that hides the passwords for the high privileged accounts and has a service by which authorized users could take custody of those credentials, passwords, or SSH keys. A zero trust, least privilege, role-based access control to protected systems and to the privileged account credentials. Command filtering was a powerful countermeasure that we demonstrated in a prior session. That includes the ability to block commands based on a blacklist or a whitelist type of approach. Session monitoring for user accountability. That is video session recording with playback, DVR-like style, so you can see every screen, every mouse click, where you came from, ensure that the video itself has not been tampered with, and tying particular actions of a shared account potentially to a named user. That has the effect of not only providing accountability to the users, but the fact that people know they're being recorded is going to alter people's behavior as well. And application to application, or the programmatic use of high privileged accounts. We'll be talking uniquely about that today as our subject matter advances. So in the kill chain, or as a breach defense, the way the bad guys get in involves the use of bad credentials, weak authentication, possibly never changing the default passwords, or perhaps stolen or compromised credentials. I've made a note here that some of those might come from applications. In fact, the applications themselves, however you've secured the other credentials, the credentials that are used by your applications have certain problems that make it easy for an attacker to compromise your systems. I'll talk a bit more about that in a minute. Password or key management, lack of rotation there, shared accounts that maybe you're involved in sharing passwords with multiple people, and then not only authentication but also access control. What can you do with a privileged account once you've got it? What commands can you run? And how do we keep a complete log of everything that's happened with these high privileged accounts? So as a countermeasure, we'll help you with CA-PAM enforce your strong authentication using whatever you want to use in that space, controlling where you can log in from. We're also going to provide around credential management the ability to control what those applications can do, or which privileged accounts they can control, and allow you to remove those hard-coded passwords that can be a vulnerability. From an authorization perspective, the zero trust model. You get no access except what we explicitly authorize based on your job role. Automated login so that you can actually make this convenient for administrators, but also reduce the risk of shoulder surfing because you won't even have to handle the password. You won't have to copy and paste it when you're using an automated login to the controlled endpoint. Inline command filtering using an agentless approach through that whitelist and blacklist technology that we described in a prior session. The leapfrog prevention that is another control that's very important if you're authorized to get to server A, but you're not authorized to get to server B using this privileged account. While you're on server A, we don't want you to leapfrog out of there to start a rogue RDP or SSH session to server B. You weren't supposed to be there, so this leapfrog prevention ensures that capability is enforced. And policy violation detection, that's to do with if you're using that command broker and you do run afoul of some of the policies, what do we do about it? Well, we could notify you, we can terminate your session, we could even block your account from using PAM until such time as somebody has reviewed that activity. Continuous monitoring and logging, so that's audit everything, provide warnings, and we're going to be integrating this with some more intelligent way of handling this. DVR-like recording so that you can see what people did, play it back from the beginning, skip ahead to interesting things like were there violations. I can show you where in the video those took place and you can go inspect that actively. Activity log reporting, so this is again the accountability as who has done what inside this privileged access management session, and tying named users to the use of particular shared accounts, and integrating that with a scene that you probably already have in place. So this is one more source of event information. You'd like to get that into your security information and event management system or your syslog server. We have native ways of providing those capabilities. So CA Privileged Access Manager, to remind you, is that it's delivered in an appliance-based form factor. It's a very differentiated solution because this is a purpose-built appliance that is full-featured. It contains all the features that you would need in order to get your job done. It can be delivered as a physical appliance, as a VMware virtual appliance through an OVA, as well as an AWS AMI. The features are almost exactly the same regardless of the footprint that you want to use. So all of the features that we're going to be delivering are delivered on Privileged Access Manager through this appliance-based form factor. The appliance is purpose-built, very highly scalable. It helps you avoid hidden costs because it includes the operating system as well as our application, the database that contains all the policies. All of the features are built in, so the ability to enforce authentication, to do the RDP, SSH, HTTP, what have you, connections to the endpoint, the rotation of those credentials, the video session recording, all of these features are built into the appliance. You don't have to stand up separate hardware. It does include active high availability. It does include the ability to set up a virtual IP, automated load balancing, automated failover. So everything that you would need to do for a privileged access management implementation is delivered in this purpose-built appliance, and it will address and control access to systems that may be in your traditional data center, perhaps in a virtual or software-defined data center, public cloud such as Amazon AWS, where we have very deep integration, and we'll be diving into that in a future session, and then and SaaS applications. So a single purpose-built, full-featured appliance that implements all the controls you need. And I've highlighted here that the credential vault can be used for users and can be used for apps. Not everybody needs apps, but we make that available. That is, not everybody is going to be licensed for the app-to-app, but everybody will be using it. Everybody does need it. And so when you apply this control, that is also baked right into our the purpose-built appliance. So let's talk a little bit about application credential management and what is the reason why you need to do something about this. Well, to begin with, the applications themselves are probably designed, certain of them, to require privileged credentials. it may be a database account, the Oracle user. It might be an application account. But you started it as one person, but it needs the credentials of a privileged account in order for the application to start or for some other reason. So you might store those credentials in clear text. So if you have a shell script, for example, you look in the script and there's a credential in there, user ID and password hard-coded. Or an application might have that in a config file or an include file. That is the vulnerability, because now you have these credentials just sitting there not protected. They could be on a server, they could be on a network share, but they're not sitting in a protected space. Another vulnerability is that when you set this up, you might set the credential one time and you never change it. Why? Because it's too much trouble, perhaps. So you set the credentials one time, you rarely or you never change them, they're sitting in clear text. That's the vulnerability. And the risk, of course, is because they're sitting out there, those credentials may be compromised by anybody who knows how to read the file. All they have to know is, hey, I'm going to look at the script, and now I've got the credentials for this high-privileged account that are embedded within it. So the solution for securing this that CA Privileged Access Manager provides allows you to remove those credentials from the applications and then replace them with an alias. The developer of the app or the author of the script doesn't even need to know the identity of the shared account that's being called. That's contained on the server side or on our appliance. It knows that this alias is associated with a particular privileged account, and that account's credentials are stored in the credential vault. So the application doesn't need to know any of that. You can substitute an alias for the credentials that are currently hard-coded there. When you've done that, and there's also some stub code that goes along with that. When you implement that, the application will programmatically retrieve the credentials at the time the application or script is invoked. So there'd be a variable, for example, instead of the hard-coded password, and through a call to CA Privileged Access Manager, you'll dynamically get that credential at runtime programmatically. On that, when the application does make that call, you have the option to set up validation checks to ensure that this is the right program, that this is the right user, that this is the right credential that they're asking for, and that the program itself, that we've done a validation of the hash of the file, for example, and so we know that it hasn't been tampered with. Provide additional security before you return programmatically the credential that the application is requesting. And this feature is available for many operating systems, program languages, application servers. So this is kind of the nutshell that we'll be going through. CA Privileged Access Manager is based on an acquisition we did last year of Exedium. Hard to believe it's been almost a year, but it was really a leading a bastion host model for controlling access to systems, controlling access to credentials, and providing all the features that I was describing. And this is complementary to our Privileged Access Manager server control, which is a host-based solution. You don't have to use both together, but kind of in an 80-20 rule, you get the best of both worlds. The network-based access control through Privileged Access Manager that provides possibly 100% of the controls you need for 80% of your enterprise. And for those really high-risk, high-value servers that maybe you'd be concerned about a direct attack against those servers, Privileged Access Manager Server Control provides mainframe strength, mainframe-style controls for Unix, Linux, and Windows that can defend those servers in kind of a bulletproof way. So this is a complementary defense-in-depth approach that also works in concert and complement with other technologies that are also offered by CA, such as strong authentication and identity and access management and governance. So I told you I would pass this over to Terry Hooker, Terrence, and Kristen, I think maybe it's time to pass control to him, and he'll walk us through the product demonstration.
Yes, Terry, you have control now, so you can share your screen. We can't hear you. Make sure your line is off mute.
How about now?
We can hear you now. Thank you.
Okay, sorry about that. Okay, All right, thanks. My name is Terry Hooker, or Terrence Hooker. You might see me as an email. But anyway, I'm just going to do the demo here. I know that a lot of you have probably seen these demos before, so, but for those of you that haven't, I'm going to do a very quick demo on PAM itself, and then we'll kind of dig down into the A to A stuff as we go along. So, as you know, this is the interface for PAM. We have a number of ways to log into this. We can do local authentication. We can do a radius authentication, which is what we would use for something like our CA advanced authentication if we wanted to do a multi-factor authentication into PAM. We can do radius with LDAP. And the LDAP can be like Active Directory, any other LDAP that you might have available. And we can also do things like with PIV cards and so on. We have also a client. Right now I'm using a browser client. You do have the ability to download a client directly to your desktop and any of these operating systems that we have here. The other thing that we have is you see the single sign-on right here. We can click on that, and this is going to actually be using CA single sign-on solution to do a SAML authentication. And let me just put the correct password. Okay. And this is Michael Allen. This is going to be logging in. If you look up here on the upper left, you'll see what's connecting, and then you should see SAML tool auto post. And so that's the assertion being sent down here to the PAM solution, where it's consuming that, logging me in with, again, no password other than the SAML password being put in. Now you see on this screen, this is a standard user screen. I've only been given access to one server, two servers, one Unix and one Windows. And here on the Linux server, I have two different accounts. I can just click on this account, Oracle, and what it's going to do is just go out, log me in. I didn't have to use any kind of a password or anything, and I'm in the system. Even though that it granted me access to the system, we can still do other things with this, such as block me from using specific commands. Maybe I shouldn't use reboot or kill, so forth. Also, we can prevent me from actually doing any kind of server hopping. So maybe this is the only server I go to. If I'm trying to do something else with a buddy or something to go somewhere else, it will just prevent me from doing that. Another thing that we can do is like some type of web portal. So this person is the SiteMinder administrator. So he just has to click on that, and he's into the SiteMinder administrative UI. So we're logging not only onto the server, but we also log him onto this administrative UI, which is very nice if you only want the user to have one application, because if you just click this, just exit out of there, I am logged out of the server. So let's just log off this guy, and I want to actually log on as a super user, and I've had Firefox save these passwords just for demo uses. Okay, now you see that I'm logged in as a super user, a completely different interface from what you just saw. I can look at the license usages, the different devices and users that are under management, events, and look at the appliance status here. If you're using clustering, which probably would be doing, have 2 or 3 servers, are all going to be listed here. And again, this is where I believe that Steve was saying this is a VMware appliance, but if you had something in AWS, if you had something that was physical, even those 3 different types of appliances could be clustered together here. If you look at the access page for the super user, you see it has a lot more devices that can be accessed by this person. You can look at routers, you can look at the ESXi server, you can look at AWS servers, even log into the AWS management console, and so forth. So there's a lot of different things that can be set up. You only have the access that is going to be granted to you by the administrators of this project. We have different logs that we have here. So we get logs on everything that you're doing. As you can see, the admin, I just logged in, and it shows me that log records are being viewed. It showed me the login from here, logouts, all the different things that are happening on this server. If I look at session recordings, then we have all the different things that are being recorded. Let me just do one thing. I didn't do any kind of validation or violation of it. I'm sure I've got some, right there's anything in red is going to be a violation. And so this person did something that was not allowed for them. And you can see this is the session recording that we got from this. It shows the actual user. It's validating the SHA verification, showing the server was on it. And here you see where the validations were. And here it looks like we ran a kill command 3 different times, and then they were automatically logged out of the session. This could be just a number of different things you can do here, but in this situation, that's what we were doing. And if you're in a Windows system, this is more like a video recording where you can just record that and jump to different places on there, fast forward, so you don't have to look at that whole recording. Let's just get out of here for a minute and keep moving ahead, because I know we don't have a lot of time for this. But you have the different services. There's the Unix system, the UDP services, RDP applications. On the user side, we can manage the users. This is the user we just logged in, is Michael Allen. You can see that we did a SAML authentication, and that is the only thing that he's allowed to do. That's locked down for him. His role is a standard user, and you do have a number of different roles that could use. Everything from an auditor who would only see most likely a blank screen, but would be able to look at the logs and session recordings, all the way up to a global administrator that this super user is. Another thing that we can do with the users, if we go to manage groups, we can import LDAP groups. So you see here we have, I've imported a bunch of LDAP groups from AD. To devices, we can manage devices. And one thing I wanted to show you here that does have something to do with the A2A. We have 3 different device types here. One of them is A2A. And once you install the A2A client on the server that we have right here, what you'll need to do is click the A2A button, and you notice how it brought in the request client. Make that active, and then that will allow you to actually access the PAM server from the client. Okay, let's look at the policies. This is what ties it together. We look at the policies right here. We have here's the user again, Michael Allen, and you can see that he had the ability to log onto the site manager server, SM server, and look at the admin UI. But if you remember, he also has some Unix access there. And that was given to him through this SAML users group. So that gave him this access to the server you're looking at here, but it's just another way, a better way probably, to actually handle the grouping and the assignments of policies to different users. So you don't do it by group instead of by individual user. And here you see that here's these 2 accounts that we had to log in. Remember, we just logged in as Oracle. Then you have to use a password. And so let's get onto the other side of this, and we'll take a look at how that all works. So we're going to go to Manage Passwords, And you have another screen here that we're looking at where you can look at dashboards, reports, targets, workflow where you'd look at your password review policies where you could do different things like change passwords on view, change passwords on auto connect, that type of thing. And you have user groups and some basic settings. So before we get to the A to A menu, I want to look at the targets. And the first thing would be looking at an application. And the applications you set up, that's what we're trying to access. So in this, you see, we have this whole thing. That is where we have the client, gateway client installed, and that is where this application is, the MS SQL application. Now you see that we have a number of different applications that we can use here, as well as a generic, or if this do not have something on the list. But in this case, we're using MS SQL, and if you look at the bottom there, you have the port that we're using to access that. It's the default port, and the instance of the database, the NoSWIM database. A lot of you have probably heard that for a long time, but this is what we're doing. So this is the application we're going to be accessing. I come out of here, and then the next thing we would do is look at the account. So how are we going to actually access this application? And this here is the account name. This could be SA for Microsoft or whatever kind of a privileged account you're using. But this is what we're going to normally be using that. The user would type that in, or if we're just using PAM as a privileged access manager, where we logged in like we did with the account on the account for the SSO admin, where we just logged on like that. This is where we've set that up, and right now this is the password. So this is the account name and password, the privileged user information that would be in a script. So we don't want to have that in the scripts because any user who's able to actually access that server, could probably end up finding the script, find this information, and then he'd have a privileged access account that he could start working through your systems in. So we set this up. And then right down here, we have the account type. And instead of being a privileged account this time, it's an A to A account. And what that gives us the ability to do is set up an alias. And right here, we have an alias that we've set up, MSSQL-1. And that alias is going to actually be what is referenced in the script, and then the client will make a call back to PAM and collect the proper credentials for that and pass it on. So those are the two things you need to do before you're in here to the A2A menu. Now, the first thing you usually want to look at is I have an A2A client installed on two different servers here. This is the one where we're actually going to be looking at it today. We just click on the details. We can see the server, the IP addresses, the versions of the client, Windows versions, and so forth. One thing that I like to do is once we've activated, I just like to click on next protection status. And once we see that that updated successfully, is we have a communication between the client and server. And so this, we want to come out. The next thing you would do is look at the scripts that you're running. And for this one, we were running this script right here that we'll look at in the demo. So again, the client is going to be available through this looking glass thing. And you can see I have two clients installed, like I said, and PIN forwarding.ca. That is the one that we're going to be working with. This is the script name that we're going to be using. So this is on the server, PIN forwarding.ca, the same server that has the client. It's one of the things that is required. We have the execution path, we have the file path, and the type. And if we look at the type, I'm running this .pl script or Perl script, so that's how it's selected there. It could be Java, it could be VB, CC, C++ scripts, but in this case, this is a Perl script, so this is what we're running here. Now this hash, this is where we're taking a hash of the actual script that you're running. So if you're just developing a script, changing it all the time, you probably don't want to take the hash right away, but when you have it running the way you want, then you're going to want to get a script hash, and then we'll go to the next screen and I'll show you where you can actually make use of that. And right here, we can go into mappings. And let's just push in here. So you can see we have the alias that we're using. Once you set up your aliases, you can see there's a number of here's the alias that we're using for this server. The account name, remember, HR123. You have this client. Again, it's the clients that we have here that have just the 2 installed. And then you have the script. So this is the script that we actually set up in the script configuration page. Now, here, these are all in check right now, but what you can do is you can have it check the execution user ID. If you check that and then put specific user IDs here, then only those users would be able to actually run the script, even though they can get to the server. So if I had a policy that let me get to the server, but my name was not on this execution ID here, and we had this was checked, then I would not be able to run that script. So it's just something you can do to make it a little more secure. You can also check the execution path to make sure that's correct in the file path. And here on the perform script integrity validation, what that is doing is, remember in the script configuration, you have the ability to grab the hash. So what that does, if you grab the hash and then select this, what's going to happen is anytime that script is changed anyway, like even adding a space to it, the hash won't match and you get a violation and you will not be able to get to run that script. So that is pretty much all there is to setting up this client and setting up the different components that allow you to make use of this. So let's basically come out here, and here are 2 scripts. This is a script, remember, the sample 2 that we have set up to talk to PAM, and this is an example of it, and the way that it would be used without PAM. So you see in here the script is actually, it's looking at the server name. Remember the Northwind database, that was what we were looking at. And here's the user ID and the password, the privilege account that's used to actually run this script and go out and it's basically getting first name, last name, and phone number, and then printing it out. So we close that and just run this script. You'll see that it all works great because that privilege account information with the username and password was in there and allowed it to connect to the database and bring back that information. Now here, if we look at the one that we're actually using with PAM, you can see that it's a little bit different. It's instead of having a username, password in this script, what it has is just an alias. And remember, we had this MS-SQL-1, that was our alias for this that we set up. And it also has get credentials call. And using the alias and false, which just means it's not looking at the cache for this particular, in this particular instance. And then the main part of this is it's still going out using the ODBC driver, looking at the database, selecting employee ID, first name, last name, phone number from employees, and it's going to print out employees and then same information. And remember up here where it said get credentials, that's a subroutine down here where we're taking the alias and bypassing the cache, which we talked about, and it's set up some environment variables, and this is by default where it's going to be installed on your system, CCSPM cloakware, and it's telling it to use 32, although so we do have 64-bit, and setting up the last environment variable right here. And this is what it's using to go get that information, sending the alias in, the MSSQL-1, and getting the credentials back from the configuration that we have in there. So as you can see, this script does not have a username and password in it anywhere, only an alias. So if we come and run this, we should get the same type of information, even without having username and password in there. It just makes the call, the application makes the call to the client, and then that client contacts the PAM server, which has, with the alias, which has all that information about the username and password, and then it passes it in. And in this way, there's no exposed username and password of that privileged account within any of these scripts. And that is, I guess that's really what I wanted to show you today. So I guess, Steve, we'll be back to you.
Thank you, Terry. That was a good presentation. Kristen, I think at this point we are inviting questions. Is that right?
Yep. So if you have a question, you can enter into the Q&A panel, or you can press #6 or *6 to unmute your line and ask a question over the phone. Our first question that came in through the Q&A panel was, can CA Privileged Access Manager integrate with CA AuthMinder, now known as CA Strong Authentication or CA Advanced Authentication?
Yes. So CA Advanced Authentication, formerly known as AuthMinder, works great with CA Privileged Access Manager, and it's so there's an integration that takes place that allows them to work together. So we do have customers who have licensed both together, and they do work fine together.
Okay, great. Next question is, does CA Privileged Access Manager have a capability to auto-discover embedded application credentials that are already existing in large enterprise environments in the wild jungle, they put in parentheses? Also, does it have any auto-discovery functions for cloud and virtualization platforms?
Yeah, so the auto-discovery feature for privileged accounts is, I guess no presentation would be complete without talking about the next release. So we do have a future release that is going to be doing discovery of privileged accounts. That capability is not in the version that Terry is demonstrating today. We do actually have a connector today that for LDAP that will allow you to discover privileged accounts in that environment today, and we're extending that to other platforms.
Great, thank you. Another question, does this product integrate with CA Identity Manager provisioning?
Yes. So there are a couple of different types of users that you would have with regard to CA Privileged Access Manager. Generally, those would be in your user authentication source, like a directory. In that sense, PAM itself is actually pointing to example to Active Directory for authenticated users. The integration you would be looking for Identity Manager at that level is simply to provision a user into Active Directory, and then as a result of being in AD, PAM would pick up that change, and the user would be able to authenticate using his or her AD credentials. And based on their group or OU membership, and according to how you've written the policies, would inherit whatever access is appropriate for that group or OU. The other type of user that you might have within PAM is an internal user store, which is oftentimes those are product administrators who log into PAM for the purpose of doing administration. Anyway, there's a built-in user store that's separate from the directory that you integrate with. An identity manager has been demonstrated to integrate and works with that user store as well.
Okay, great. Thank you so much. So I don't see any other questions in the Q&A panel right now. I did, however, open a poll for you to rate this webcast. So please answer that poll and provide your feedback. It's really helpful to us just to gauge the value that you guys get from these webcasts. It's actually Pokemon Go themed, so I hope some of you can at least appreciate that. I don't see any other questions in the chat window or the Q&A panel, so if you do have more questions, please post them there, or you can press #6 or *6 to unmute your line. If you're using the audio broadcast, you can select the phone icon with a question mark, and that will enable audio through your laptop once I approve you to become unmuted over your laptop microphone.
Kristen, just to add a little color to my initial response regarding integration between CA PAM and CA Advanced Authentication, that's done through Radius. So we have a Radius integration natively in PAM, and Advanced Authentication also supports Radius. So it's a very simple integration to set up the two together using that Radius in the middle.
Great, thank you. And also, if you didn't see it, I put the link to the blog post in the CA security community, which contains links to all of the replays and slides from previous webcasts in the series. And I will continue to update that blog post with the link to the slides and the replay from this webcast. And I'll also send that out in a follow-up email. And I'm going to also post a link to the next webcast while we wait for more questions to come in. All right, I don't see any more questions coming in, so we'll go ahead and close this out. I want to thank you both, Stephen and Terrence, for your time today. And if there are any other questions that pop up, I'll make sure they get to you guys. You can ask other questions by replying to the follow-up email or by commenting on any of the collateral related to this webcast in the community, and I'll make sure those questions get to Stephen and Terrence. Thank you, everyone, for attending today. I really appreciate you giving us your time and attention on a Friday, a sunny Friday if you're in the Northeast. I'm in New York right now. And I hope everyone has a great weekend, and we'll see you at the next webcast next Friday, again at 12 Eastern Daylight Time for the next Privileged Access Management Lunch and Learn webcast. Thanks, everyone.
Thank you.